spend too much time answering the questions. So I want to keep this one a little bit shorter. I think we're gonna pour all the next workshop kind of the same format. So I think we should start with a small update on latest PRs, which some of you actually contributed to. So that's really nice. Then I'll give you guys a small walkthrough on how the bot actually works, like on a pseudo level. Maybe you can link some visual code sections to it, but just like in a actual manner, like how it works. Then we can do some future stuff we're working on. We want to integrate, and if you want to like contribute, that could be stuff you could be working on. I could start working on, and happy to help you there. So first off, let me see if I can share part of my screen. Let me see. Oh, by the way, this really doesn't have to be me speaking for 40 minutes, 45 minutes. So if you have any questions and you're not like scared to talk, just unmute or raise your hand and just start speaking, because there's not too many people around. So feel free, or else drop it in the chat. I think Ponzi Ninja will keep an eye out for it on the chat, so he'll pass on the messages if I miss them. So feel free to ask all the questions you have. I'm really happy to help you all out and to make sure we can improve the bot and teach some people about arbitrage, how the bot works, how we can improve, and all that stuff. All right. So first off, a little bit of the change log. Recently, last week, we merged the release branch into the main branch. I made a small, I made a small change log of, or at least a summary of the most important stuff.
Bossa Nova, you haven't. Yeah, I see it now. Okay.
It's Friday. Take it easy.
Yeah.
Don't get all. No rush.
Can you guys see the screen sharing now?
I think it's good.
I can see it.
Right. So, guys, few things we changed. A few big ones actually. For some, they are, some of you reviewed them, or they seem quite, or you already know what's in there. But for others, it might be a bit confusing. So I'm gonna explain what we kind of did in here. Some things are still work in progress, but it's a start. So first off, what we did is we handle protocol fees right now. What this does is, in the previous state of the bot, we didn't really make a difference between what kind of trading fees DEXs use on their pairs. A lot of the DEXs use something, what we call protocol fees, which basically means part of your trading fee, like usually like the 0.3% you're paying, is not staying in the pool as a reward for the LP providers, but actually leaves the pool for the protocol. So basically, it will go to like I don't know, like a treasury or some DAO that holds the revenue that they are making out of this protocol fee. So what does this mean for us? It means that the underlying state of the pool is affected by this protocol fee. Why? Like the LP fee, so which is like the other part of the fees, they stay in the pool, right? So they are still part of the pool state. The state, I mean the balances of like the tokens in the pool. But the protocol fee actually leaves the pool and thus changes the underlying state. What caused of what was like the implication of this? What did this do in the bot? It kind of created a lot of the small errors we've encountered when we were running on very small margins. because the states, I mean, the fees are not huge, but still, like the underlying state of a certain pool was a little bit different than what the bot, thought it was, and therefore we got a little math errors, and the bot sometimes thought it was already armable, above the threshold, but then it really wasn't because the protocol fees actually left the pool. So that's quite a big one. Next one, we added a cooldown feature to the pass-through ARP. Basically, this means we're not over trading a path. So instead of just waiting in the code, we now add a flag to a certain path that we already traded it, so we don't want to trade it within 5 seconds or within a few blocks. And also, and this is also I think a big one, we now calculate the fees specifically for each path. Why is this relevant? Because I can clarify a little bit. If, for example, if we use a 3-hop ARP, let's say Juno USDC, Adam, Juno, whatever. These are all natives. This will result only in 3 messages in our flash load message. Yeah, we use on the white whale flash load router. However, if we use something like Juno, I don't know, Neta, something else. I don't know, guys. I'm just loop, Juno, for example, right? This uses, at the top of my head, 1 native, which is Juno, native token. I mean, with this native asset, and 2 CW20s like Neta and loop. Now this results in more messages usually. And thus higher fees. In the before state of the bot, like in the previous state of the bot, we calculated the fees based on the amount of pools in a certain path, which means like a 3-hop ARP, the one above would get assigned the same fee, expected fee that is, as the second 3-hop ARP, because there are both 3 hops or 3 pools in the path. This is incorrect. In fact, you can use lower gas fee and thus transaction fee for the first one, and this second one has to be higher because it's like maybe 3 or 4 or 5 messages, so you need more fees. So we now calculate on initialization. We calculate the fees based on every path. So what we do is we simulate a trade on each path, right? So for each path we are gonna ARP. We're saying like, let's pretend I'm trading one Juno across the whole path. How many messages does this mean? And then we set a fee based on these amount of messages. So I hope that clarifies. Yeah, we had a bug in the profit calculation. Also, probably the reason why a lot of you encountered so many error 8s on Skip's end, which is like something's wrong with basically something wrong with our message, which 99 out of the 100 times means we made a little boo-boo in the math somewhere, or the state is not like the state we predict the pool to be in, or the state we want to ARP is not actually what's encountered on chain. So that usually results in a error 8 code from results from Skip. We fixed a few things on the profit calculation. Some guys in the Discord, I think this one was from Carl. He enabled the Docker Compose stuff. Yeah, so you can now spin up multiple containers at once, basically using Docker Compose. Really neat. We added some sign of life in minutes, which is a feature for the loggers. Instead of having to assign a sign of life message, which is basically just like a logging message that will be sent every X iterations to you, saying, "Hey, I'm still running." If nothing's going on, we changed that to being a sign of life in blocks to a sign of life in minutes, because Injective has like a very low block time compared to Terra, for example. So it's really not handy to use amount of blocks in there or amount of iteration in that regard. Then the guys, thank you all. Some people added Telegram loggers, Discord loggers. The Slack logger was already in there, so that's really neat. We added something to override skip errors. For example, skip error code 4 means the next validator or the proposing validator is not a skip, is not running skip MEV. Yeah, we can't really do anything about this, right? So yeah, it happens quite a lot, especially on Terra. So you can enter code 4 here saying, I don't want this on my external logging. It will still log to console, so you can still view it, but it won't spam your Discord anymore or your Telegram, whatever. So I don't use this because I want to see how many times I get this skip is not running on a validator. Still, another neat thing that's not really something we changed in the bot, but something what will changed on the flash loan, but it's very relevant. We are now using, for everybody's listening, we're using 0.15% fee on the taken flash loan instead of 0.3%, so we halved it, which is very relevant for small margin arbitrage. And we updated all this stuff written above in the new environment variable examples, and I've updated the docs so they should align with the new example. So if you want to check out the new stuff, it should be on docs white whale money / white whale docs, but we have the links on Twitter or whatever. These hold the new updated examples, if I'm correct. So moving on, if you guys have any questions, let me know. I don't think there's a lot of questions. This will be recorded, so you're free to listen to it again. So now I prepared a small little diagram to explain you guys, like in a high level or high overview, like how does the bot work? How does any bot work that's trying to do arbitrage, but how does this one work, like for simplicity in a simple manner? So I will try to share this. It's not like and I hope you guys understand, or it's clear to you guys. Let me see. Yeah, so Engineer, you're seeing this image?
Sure. Can you zoom in a little bit?
He's gone. I assume you guys see this image. Thank you. Thanks for the confirmation.
Sorry, I was on mute. Could you zoom in a little bit? Yeah, perfect.
Yes. So, okay, without zooming in, I've separated two parts of the runtime. So basically, we have an initialization phase and a continuous phase. The initialization is everything that occurs before we actually start running the bot, like reading the bot config or creating the bot config from the environment variables and some initialization done on the config, like create all the pools, create all the paths, which is, by the way, I didn't add this to the changelog. We now do this via graph search, which is way faster than the brute force stuff we used before. Therefore, we can easily ARP four op paths, so paths that include 4 different pools. It sets up like the connection to the specific chain. For instance, you connect to Terra, you use like uLuna as a as a base denom and all that stuff. But it also sets up the logger, so either the Discord, Telegram, or Slack, or nothing at all. It's not like required. then an important decision for the continuous part is whether or not you're using skip protocol to submit bundles, or you're just doing mempool arbitrage like the old school first in, first come first serve arbitrage, and therefore gambling that that the next, like the validators you want to shoot your arbitrage messages at are not running skip, because if they are, and you like, even if you're really fast, if it's running skip and someone submitted a bundle to skip, it will be like it will get priority over your transaction, so you basically you will lose. Okay, can you check for this? I don't think so. Since you're running speed arbitrage, every check you do is a waste of time, so you just need to shoot as fast as you can. So for my example, we really focus on skip, because I think, yeah, that's what a lot of people here will be using, and I don't think many of you will run an actual professional arbitrage setup, latency wise, and all that stuff, node wise, and all that, yeah, you know, all the things that matter. So we'll just focus on the skip implementation right now, which is basically an extension of the mempool loop. Okay, so it's not that different. We just handle the memory pool a little bit different, and we we trade using the specific skip endpoints they provide. All right, so once we have the bot config set up, we'll move in the continuous phase, saying keep on running a step until something else happens. All right, so keep on doing the step. What does the step look like? So the step, the first thing we do is we update all pools. Yeah, I'm not sure if it's, I could share something else here, but from the config we already know like I should be able, yeah, I can show this right now. Wait, let me see. To give you guys a little bit more. Right, I think you guys can see full screen now, no?
Yeah.
Yeah, so what I do with this is the initialization phase, right?
Do you mind zooming in a little? That's
I don't know how to do it. Wait, let me do it like this. I think I can change the size. Where's this again?
Because at least on my screen it's really bad quality, so people won't be able to see it on the video.
Yeah, all right, I get it. Let's see if I can zoom in a little bit. Always when you look for this. Right. How's this, Nico?
Yeah. That's
All right,
perfect.
it hurts my eyes. I'm running on a 4K. I feel like a very old man, which, you know, maybe I am. Anyways, happy it worked out. So this is like the setup phase. Print a few of the environment variables. So we're running on Reese's Judo endpoint. Thank you, Reese. Our offer denom, which is like the base asset we use, Juno. We have a few prints. We went over most of these config settings in the previous workshop. So if you want to see all of them, just click on that one. It will be up. It's uploaded on the White Whale YouTube channel. Running skip. All right. Some connection details, some account details, and then this, like the result of the initialization recreated. This is 4 hops, so I'm using 4 hops, so either 2, 3, or 4 hop paths are used. Created a total of 1,598 paths, of which, you know, 30 are 2 hops, 166 are 3 hops, and not surprisingly, the most are 4 hops, because, you know, it's just more combinations. And then we removed 6 unused pools. For this example, I think I used I use the list of variables. You can't read this. We use the list of variables provided in the example. It doesn't make sense to share this now because I have to zoom in. But I use the list that's provided in the documents or in the example environment variable file. So you should take the same. So that's kind of the end of the initialization phase. Then we move into the step part. The step part is first we update the pools. So this is something different than updating the paths. So we are updating the individual pools that we have listed in our pools variable in the environment settings environment variable file. We're not updating 1598 paths. All right, we're only updating the pools that form these paths. Okay, so I think they're about like 50 or something. I don't know, 50 something maybe. So we're querying them async. Give me your balance of your tokens, right? So how many, for instance, a Juno USDC pool, how many Juno is in there, how many USDC is in there. Because on the arbitrage we do on the AMMs, so the automated market makers, these balances, these ratio, they denote the price of one asset with respect to the other. Then first off, before doing anything mempool, we check, is there already arbitrage? This is what I call state arbitrage. So is the current chain of the block state of the blockchain, does it already show an opportunity of arbitrage? If so, then try just create the flash loan message for this. I'm not gonna dive too deep in this, but create the flash loan message. We can spend more time on this later if you guys want. And shoot it to skip, so trade it. Difference between these two trades, the first one, we trade without a mempool transaction bundled. So we're just saying to skip, hey, give me this. I want to trade this transaction. I want to do this message. Put me on top of next block, on the next block. I'm willing to pay X amount for it. So your skip bit, you're paying your skip bit for this. But we're not pairing this one, or we're not bundling with a transaction in the memory pool, right? So this is possible. That could hit, all right? Usually this is not the case. Why is this not the case? Because the second part. Because the stuff that happens below here usually prevents state arb to occur. Then, if there's no play arbitrage on the current state in the blockchain, which is usually the case, query the memory pool, which means query, give me all transactions that are lined up to be included in a block, but they're not yet included. So they could be like they can also be like false transactions in a sense. Someone could mess with you in this one. I could pretend to send like 1 million Juno trade into the memory pool. This one will never be resolved because I don't have this, or maybe I do, but but then it's in the mempool. So the mempool is like a wow. It's like Wild West, right? So it's not really as smoothed out. Like there's transactions in there that will not reach the actual blockchain. So we query this one, and we check whether or not this means we have a new block. We can compare this with the previous mempool state. I think I can clarify this a little bit more. So what this means, I'll just open up the code. See, I think I need to zoom in on this one as well. Zoom in. What's this? All right. Can you read this, Nico, or no?
Yeah.
Barely.
Barely a little bit more.
Right, like
yeah.
this?
Yeah, perfect.
Is good? Okay.
Yeah.
All right, so ignore most of this. This is it doesn't really matter where this is. I just want to explain briefly on how we handle the mempool before diving into all the transactions that occur in the mempool. So what do? We query the mempool right here. So we say, give me the new mempool. Then we're saying, all right, if our memory pool, our new memory pool, the just queried mempool, has less bytes than the thing we were just processing, and break out of what we're doing, which means this break, go to the reset. What does this mean? If we have less bytes in our new mempool than what we are currently processing, is that there has been like a new block, right? That only can mean there's a new block, because that's the only way, like, well, I think, at least for us, it's the only way that we get a new block. If the bytes, like the size of the mempool has shrunk, because that means like there's transactions gone there, which means they were included in a block, and thus we have a new block. Then we break. I'll handle the break, what this means for us later. If the new mempool is equal to what we were in our previous iteration seeing in a mempool. So usually this is 0. There's nothing in the mempool. Right? So we obtain a new mempool, doesn't have anything. We already knew that. What are we doing? We're continuing. So we're not checking for R, blah, blah, blah. We already did this. We just go to the next iteration, which means query the mempool again. So usually what will happen is the bot will query the mempool, reach this verdict, like, nothing changed, continue, query it again, query it again, query it again, all the time. If neither we have a new block, or nor do we have like nothing changed, then we assign like our new we just say like, all right, this is the new mempool amount to check, to like keep in state. We just like override it. So what does this mean? What I just said, like this break, this means we have a new block, so we reset, and I'll run it. I'll go through the reset function a bit later. It's not too difficult. It's pretty plain, like. And then if we don't, if we don't, so like what I mean with this is, in the case that our new mempool is bigger than what we were just analyzing in a previous iteration, so neither of these are true, then we say, all right, this is my new mempool to check, which basically means there's a new transaction in there, okay? There's a new transaction, so maybe we should do something with this. So then we reach this part. So is the new block? No, because the amount of bytes increased, so we don't have a new block. By this new transactions, assuming it's 1, try to like decode this and apply it on our pool states, right? So what we're trying to do here is we're trying to replicate our pool states is the state of the chain as of now, yeah? The mempool will be applied on this one. But what we're trying to do in this MEV is we're trying to calculate how will this pool state look after the mempool transaction is applied. Why? So we can arb it before it ever reaches state. Okay, so that's what we're trying to do. We're trying to be one step before the state arbitrage, okay? So then what happens here? We say, okay, all right, give me the new mempool, try to decode whatever that is that entered the mempool, trying to decode this, does this, and apply, right? So decode the message, all right, we obtain a new swap message, apparently some whale like Nico swapped 1,000,000 Juno, apply this on the local states. Does this now mean that this will result in an arbitrage opportunity? If so, we're telling Skip, trade this message, that like the ARP message, yeah, again, the flash load message, but bundle it, combine it with the transaction from the mempool that will cause this ARP to occur on state, right? So that's really important. So this transaction in memory pool, it didn't actually hit state yet, okay? So it's still in the memory pool. But we're saying to skip, we want to bundle ourselves, our flash loan message or our arbitrage message with this memory pool transaction and put us on top of the next block. What this means is if you win this auction, because we're paying this to skip, we're saying I want to pay X amount for this. Usually, this is a fraction or ratio of the profit you expect to obtain here. Okay, yeah, because that makes sense, right? And then if your auction wins, so you're the guy, with the highest bid for the next block, and it's a skip validator. Unfortunately, not all validators are running skip, so it's not file proof that in that sense. You're saying, all right, put me on top of the next block with this memory pool, which will be included in the block anyways, right? Put me directly after it, so don't allow anyone in between. And this kind of ensures you to be the one that ARB this transaction applied on the pool states with your own flash loan arbitrage message. All right, and then yeah, so basically then you win the bundle. So what happens if someone is running a mempool loop? So he's not doing all this fancy skip stuff. He's just shooting a message like, you can also do this, apply a transaction on mempool on state, but you don't use skip. If he tries to get, say he's really fast, so he submits his transaction before I do for next block, but it's running skip, I will still get priority. So his will fail and he'll burn like transaction fees. Okay, so that's really important. With skip, you don't burn transaction fees on failed transactions because skip will return like you didn't win or something's wrong. So okay, so that's really important. Now, what if there's no arbitrage? Do we have more transactions in the mempool? Like, you assume there's one, but maybe there's two. Yeah, then apply that one, like one by one, we go through this applying of these mempool transaction. Important to note is that whilst we say there's no more mempool transactions, yeah, and we query again, do we have a new block? No. Then apply these transactions. Important to note is that we store our transactions that we already applied in a cache. Yeah, so we make sure, say we we obtain transaction X in here, blah blah blah, we edit no R, blah blah. We don't want to query this and transaction X is still there. We don't want to apply it twice, right? So it checks, the bot checks like to ignore this transaction, like I already applied this one, blah blah blah, and then it just keeps on going. So then what happens when there is in fact a new block, so everything we try to calculate in the bottom part like will be applied on chain. So then yeah, you either have like a winning bundle from skip, then we go to the reset, and on the reset what we do, it's not very fancy at this point. Let's see, this is gonna be, oh sorry. So we reset. What do? We set all paths that we try to trade to a false cooldown because we have a new state, so we can try this path again. We set the mempool back to 0, right? Because there's something happened, and we flush our transaction memory, which is this one. Like, so we flush our cache from the memory. Then basically we start over again. Like, all right, there's a new block, give me the new states, and then we rinse and repeat this. Now, why do we have to query these new states if like nothing happened, right? But we have a new block, but nothing happened like that we were interested in. At this point, that these are like swaps, right? And swap operations like multi-hop swaps, terraformer swaps, all these things that could resolve in an ARB situation. So why do we have to update the state anyways, even though we know like nothing happened? Because we're not applying all the transactions that could be relevant as of now. I mean, we could expand this. We could like create more messages we want to decode and apply. For example, we are not applying the providing or withdrawing liquidity messages to a certain pool. We don't apply these yet. That could improve the bot if we did, because like, if we have like a shallow pool, especially new pools, they're usually pretty shallow, so there's like a few $100 in there. It's really hard to art this because you will like how the XYK pools work. You'll just cause an imbalance, and this you can't really. You'll pay for this, and therefore there's usually no art. But like if we see in the memory pool someone's like adding 1 million liquidity in there will be art there, right? We're not doing this yet, so that's could be an improvement. So therefore, we actually have to update the state because something else might have changed the state of the pool that we didn't know. So we have to reset and do the whole loop again. So this is like in a nutshell. I don't know if this still counts as a nutshell, but this is like the high level overview of how the bot works. And this is the skip version. For the non-skip version, what's different? Well, the trades, we don't trade on skip. Also, we don't apply each transaction separately. We apply everything in a mempool, and then we trade. Because we cannot pair, right? We cannot get priorities with one specific transaction. You have to deal with everything that's in the mempool, and you will arrive after this one. So, you need to apply everything in there. So yeah, that's like the stuff I prepared for today as an overview of how the bot works. I don't know if it was, if there's questions, you feel free to ask. You can also ask them in chat. Happy to answer. I think that covers most of the bot functionality at this point. Let me see if I have anything that I want to add to this. Where's this? I think that's it for now. There's a little bit more to it, like I said, like the message generation, stuff like that. But let's not make this another 2-hour bot workshop. So I think this will also summarize the bot pretty well. Now then I have something else, like what are we trying to do in the near future? I could go on and on this list. What are we trying to do? We're gonna build liquidations in here. So at this point, this is just AMM arbitrage, like between dexes or in one dex. We're gonna add liquidations in here. They will make up of a new type of path.
Bosanova, do you mind zooming in a little again on this?
Yeah. This one.
Here we go.
All right, let's go. Like this?
Yeah.
Good enough?
Yeah.
Right. So liquidations, we're gonna work on liquidations soon. If you're interested in this and want to cooperate or collab on this, reach out. I think a few of the Comdex guys in there. Shout out. I think we're gonna see what we can do. Interesting stuff there. I've been running the order book versus AMM arbitrage on Injective. I don't know. It depends on how big your bags is. It made some money, not a huge amount, but it's also because our pools on Injective aren't very liquid at the moment. Only one is, and we just noticed by providing more liquidity to the other pool, which is paired to like an order book on Injective on Helix, that we just encounter more trading on this one, and thus like more fees, but also like more profit. So our proof of concept is like successful, and we're gonna make this production ready. So we just have to like get a good design on this, because it's something different, right? An order book is something different than an AMM. It's gonna be real fun because we could apply this on Kujira, we could apply this on Injective, We can apply this on Comdex as well. We can apply this on maybe at some point at Say. So what we're trying to do with this bot, we're trying to not make this an injective order book AMM bot in any set. We try to make this an order book AMM bot, so that will work for different types of order books, different types of chains, basically. And that's I think that's very important for White Whale to make sure this is interchain focused. In fact, Nick, I think he's also in the Discord, and myself, we are thinking about a different way to handle path timeouts, which basically means at the moment what we encounter is that when we trade one path, we set it like to a cooldown. We're saying, yeah, you don't trade this path again for like three blocks or whatever. But there is a lot of pairs that are pretty equal to this pair, or to this path. I'm sorry. So, like, say we have a 4-hop arbitrage and we end up with a Juno USDC pool at the end, right? So just to get back to Juno, there is most likely a path that will have 3 of the same pools and only have the 4th pool a different Juno USDC pool, which are usually pretty well, pretty liquid, right? So that one could still be profitable. However, if 3 of the 4 pools are equal to the one we just arbed, usually this path won't be profitable anymore. So we're trying to make it like also time out the pools that are more or less equal, or sorry, time out the paths that are more or less equal to what we just traded, which is arbitrary. Like, when is a path equal? Like 3 out of 4? Or what if we have a 2-hop chain? Is it like or 2-hop path is like, is it equal if 1 out of 2 pools is the same, or so that stuff. We're designing or thinking about at least multi-chain stuff. We also with Skip. This is still, it's not like we're building this already, but we're thinking about this. We're designing solutions for this together with Skip. It's really interesting because it raises a whole new spectrum of problems. Then something I think a lot of you guys will enjoy is instead of having to fill in all the pools in the environment variable, we can query them from the pool factories that a lot of dexes run. It just has a few concerns, like what do we do with pools that don't have a factory, like for instance the Juno swap before, or Hopper's dex on Juno. What do we do with them? And if fees are not queryable on chain for certain pairs, or so for certain pools, what do we do? Do we use like a default fee setup? So what if that's wrong? You end up with a bunch of errors, like stuff. We're working on Hua swap. There is Chihuahua recently had a second dex arrive there, so we could run our bot there pretty easily, I think. So we can implement this. Yeah, there's a lot of new stuff that I can go on and on with this list, but I think these are like the most interesting things we're working on. What we'll also be working on, what I see in chat, which is a really good one. I don't know what the best RPC endpoint is on Terra. It's a bit like, yeah, I mean, we have our own private endpoints, so yeah, I know it's not really fair, but yeah, it's public endpoints will be a problem. What we will have to build is what we were already building, like the RPC switcher, which is basically provide 20 public RPCs, and if one error, just switch to the next. And switch and keep on going until like you're blocked out of all of them, and then you have to wait for a bit. But this will improve uptime for a lot of people that don't run their own nodes. Then yeah, yeah, that's the stuff that I had on my list. I know Ninja Ponzini wanted to add something. Yeah, there's a lot going on with White Whale, with Migaloo and stuff, so we have to pay some attention there as well. But I think the list is long enough. I hope you guys, gave a little bit of an idea on how the bot was designed to work, and how it works and all that stuff. So, if not, ask questions.
Yeah. There's another question in the chat. Doesn't need to be a public one. Anyone knows a provider? So he's asking for any RPC
Yeah, I don't.
endpoint.
Usually, what people use is Cosmos. I think you're already using that one. So usually people use like the Cosmos directory nodes. Yeah, nodes are just a pain. Maybe there will be some protocols providing public endpoints. I don't know. I don't think you can use like the TFL public nodes. I think they will block you very much for a lot of times, so it'll be difficult. So maybe for Terra it's a bit different. On Juno you can use there's multiple nodes that work pretty well. Yeah. Yeah, it's a lot harder if you don't have nodes that you can use. So. All right. Anyone else?
Any other questions? Severin is typing. You guys feel also free to unmute yourself, right?
Yeah, I think Bob is sharing some nice guidelines on how to spin up your own node. I don't know what the costs are for this one. Yeah, good question from I don't know, is it Crypto George or Jorge? It really depends on where you are in the world, I guess. Yeah, so I can show you like I can show you a few probably. Let me see it. I don't. All right, let me just check this for you guys. So for example, I'll be just opening the Juno environment variable, the example that I shared online or on the docs. Let me open one for you guys that's on that is on the Windex. Right, so you can't read this, right?
Yeah.
Like this? Is
yeah,
this
that's
okay?
fine. That's fine, yeah.
Right. So for instance, this is the Windex pair of the WinDAO, the DEX that they launched in WinDAO. Good thing they launch I think they launch all the pools with the same factory, like what Whale does as well. So usually all the pools will be having the same fees unless changed, okay? So this is Minscam, by the way. You should be familiar. So what we're looking for is in the config, we're looking at the pair info. We see which kind of assets does it hold. So this is a CW20 token. This is a native token. This is the address of the pool. This is the liquidity token, if you provide liquidity, blah, blah, blah. Type of pool is important. This is XYK. This is the default one. Also something we're gonna add, by the way, stable swap pools. There you have it, fee config. This is, I think, queryable. I'm not sure. I think it is. So you could query this contract saying, I think something like fees. I'm not entirely sure, but it should be. I think this one's queryable. And you see this is 0.3%, right? 30 BPS. Now, what's also important is this one. protocol fee, like I explained in the start of this workshop, some fees leave the pool that does affect the actual pool state, which means it affects arbitrage. This means like 33, so a third of all the protocol fees or trading fees leave the pool. So that's like 0.1%, right? If I'm any good at math. So this is really important. So where do you edit? Would you add this? This is, let me see if I don't share like on the mnemonics in here. This is unreadable. Is this readable for you guys?
Yep.
So this is for now. It's unreadable for me. All right. So let's see. Where's my? All right. So let's see if I can actually find this pool. This one. So what would I set this to? So it's this pool. This is the address that I shared. Input fee is 0 because Windex uses output fees, 0.3%, and the LP ratio is 67%, which means like it's just like 1 minus this one, right? Because I'm interested in the part that actually stays in the pool. You can do whatever, but I chose to use the LP ratio, which basically means the ratio of the fees that stay in the pool. Like whatever, you can choose the other way around. I chose this way. Let me check another one. Let me check like a white whale pool. I'm correct. This is a white whale. Yeah, this is a white whale pool. So it actually says white whale pool. It's nice. We got the assets again. I said, well, where's this config? So we got the assets info on the pair info, assets info, asset decimals, and I think in the config we see pool fees again, and we see protocol fee is 0.001. So this is 0.1%, and our swap fee, which is the LP fee, is 0.2%. So as well for white whale, we can use 0.3. This is the total. Total of these two is 0.3% on output fee, and also 67. Like 2/3 of this stays in the pool, and 1/3 of this leaves the pool. Yeah. Like why for you as a user, as a swapper, it doesn't matter like who gets, like you will receive whatever minus 0.3%. But for the state of the pool, it matters how much leaves to the user, how much goes to the protocol, how much stays inside the pool. Can I do another one? I can probably show you one of the hopers. I don't know if they still exist. I don't know. Yeah, this is Hopers Gelato. So Hopers is a fork of Junoswap. Not very interesting. It's a funny one though. They use 5 out of 1,000, so 0.5%, and they use another, which is really annoying. They use 5.5% burn fee on their Hopers token. So this one is tricky to implement. So we kind of went like the easy way. The Hopers is a little bit like, yeah, it's a little bit different. So I use Hopers with a 1% input fee, because Hopers is a Junoswap fork. Junoswap uses input fees, not output fees. Nothing goes back to the LPers, which is good for y'all to know. All the fees go back to these developers. Good for you to know. Except like half of it, which is used to like burn. But nothing is going back to the LPs, as far as I know. Maybe they shoot out Hopers incentives, but from the trading fees, nothing goes to the LPs. All right, one last one. Let's see if we got another one. I think this is like, this is one from Loopdex on Juno. Yeah, they also use a different different notation. So they use 1% fees, and they shoot 80% of this to some to the admin. Okay, which means I know that they use output fees, although their contracts aren't open source, or maybe they recently open source. So 80% goes to some wallet, which means 20% of this 1% output fee is for the LPers. So this is how I do it. It's gonna be a little bit tricky to automate this, do it all via queries. We will try at some point, but there will be errors. There will be errors. So it's a trade-off. So these are, I think, the most important ones. You can play around a bit if you have a little bit of problems where you want to be on the safe side. You could like up the fee to 0.01 or 1.01 and all that stuff, but it's not necessary. So this is how I usually grind my way through the list. Yeah.
So the second part of the question was, what if our fees are wrong? So if there's apparently a wrong calculation in the fees or something.
Yeah, so it's really important, this decision, whether you're using skip or no, is really important. If you're using skip, you'll end up with a bunch of errors, but you're not burnt fees. You'll usually get like error 8s, like something's wrong with your message, which probably means you're trading X amount in, you think you're receiving Y amount, but you're not receiving this Y amount. So like the flash loan message will basically give you an error saying like, this is not really what will happen if I execute this. So basically you end up with a bunch of logging errors. If you don't use skip, you'll actually burn fees. So it will just shoot transactions and keep on shooting if there's an error. So you have to be careful with that.
Okay, cool.
All right, I think that rounds it up, sums it up, or whatever. I hope this was informative, and let me know if you can also ask questions in Discord, and let me know if you have any questions, and you can do your talk now. Nico.
Yeah, thanks everybody for attending. I hope you took something out of it. Yeah, like Bossa Nova said, like he's very available in the Discord, especially when it comes to questions regarding arbitrage bots and skip. So feel free to ping him anytime. Other than that, yeah, thanks for attending, spending your valuable Friday time in our workshop. I hope to see some bots arbitraging in our pools. That would be really awesome. And yeah, let's see where this thing goes. I guess see you in the next one then. Have a good one. Have a good one, guys.
Thank you guys. Have a good weekend all.
And of course, this will be recorded. So and we'll post this on YouTube for sure. Yeah.
Bye.
So bye bye.
Bye bye.